Welcome to Unit 6, Lesson 8-ish, and the study guide review. So it's just Lesson 8-ish because we are going to cover some new material in this lesson, but it's not a lot of new material. It's like a little bit, and then most of this video is going to be reviewing for the Unit 6 test. Now, full disclosure, I am recording this at home, and there is a lot of construction happening on my unit. So if you hear things like hammering and saws and people in the background like talking and yelling, it's because there is a construction crew right outside the window over there, and they're working hard on what for us, at least when I'm recording this, is a long weekend, but not for them, and they're working and it might be kind of loud. So if you hear stuff in the background, that's what's going on. Okay, so now, there is a benchmark that's in this unit that was not previously in Algebra 2. It wasn't something we had to cover, and it's new. And so I want to make sure that we hit this benchmark in our section unit on exponentials and logarithms. And that particular benchmark is interest. It's a financial application. There are tons of applications of exponential and logarithmic functions. It's probably, after lines, the most applicable of all the families of functions. And unfortunately, we kind of get to it at the end of the year when we're looking at our EOC and we kind of have to rush through it. We don't talk a whole lot about how applicable they are. One of the applications, though, is financial. Now, just again, in full disclosure, I did not study money in college. I studied a lot of engineering and I studied a lot of math. I did not study the financial applications of that. So this is a very, very basic explanation. Like I think I wrote here, super simple. Okay, so you put money in the bank or some kind of investment account, and hopefully at this point when you're in high school, you do have a bank account that you could draw money from or put money in as you are working. Now, that money is called like the principal. It's the initial amount of money that you invest. And in a lot of problems, it is represented by P. Now, sometimes you'll see it written like this, P with like a little zero beside it. Now, I was always taught to say that P naught, that's N-A-U-G-H-T, naught, as in it was all for naught, or it all came to nothing. Okay, so like it has to do with like at the time being nothing. It's the initial amount of money that you put into your account. Now, you might also hear P0. You could hear P sub 0. You could hear P at time 0. Okay, so there's a lot of ways that you could hear it. Or sometimes you might just see a P and then they'll use something else for the final amount. Now, the bank invests, lends this money out, and pays you for letting them use your money. Super simple version here, okay? So you give your money to the bank. The bank does not like necessarily like store this money in a vault, which is why bank runs can be a problem. They lend that money out, and they are willing to pay you for the use of your money. Again, super simple version. The money they pay you is called interest, and it's expressed as a percent rate. Okay. Now, simple interest is calculated by finding the percent of the principal and adding it back in. So I do need to have a calculator, and most of my calculators are at work, where I am not at work, and apparently I have text messages because I do have to be somewhere later. Okay, so you do need a calculator to do this. So suppose you take $2,000 and it pays you 4% interest. How much interest will you earn, and what is the new balance? Now, I want to make sure that we're looking at the two different questions, because on a multiple choice test, you can be asked either question, but probably not both. All right. And so you do need to read the question carefully, because this is an easy spot to trip up on. So basically what we would do is we're going to find 4% of 2,000. You know, when I taught middle school, we spent a lot of time, especially in seventh grade math, doing this. So the way I would teach my students, well, one of the ways I would teach my students is this. We need to know what is 4% of 2,000. Okay, because that's how much interest we're going to get. Now, in order to do this, you do need to express your percent interest rate as a decimal, and that's going to hold for all of our formulas. So you do need to be able to turn that to a decimal. Now, literally, the word percent, okay, if you think about the language, it means out of 100, or like per, we'll just say like per 100. Think about like your foreign language, or the things we know about like CENT in the English language. So a century has 100 years. There are 100 cents in a dollar. So it literally means per 100. So what you would do here is you take the 4 and you divide the 4 by 100. Okay, because that's what percent means. It means out of 100. Now, other ways you might see that is you might be told, take the decimal point and move it 2 spaces to the left. That's because when you divide by 100, that's what's going to happen. Okay, every single time. So if you take your calculator and you put in, I'm going to write at the top of the screen here, 4 divided by 100, it's going to end up being 0.04. In other words, you're going to take the decimal point that was at the end of the 4 and you're going to kick it over 2 spaces. So it'll be 0.004. Now, that is stuff that hopefully you've been taught in the past, but I know that most of you don't do this very often, or you were taught kind of like methods for doing this, like multiply this by this, and you didn't really know why. So 4% of 100. So I'm going to go ahead and erase my 4 over 100 because that's just awkward. Why would I want to do this with a fraction if I don't have to? But it is important to see where that comes from. And you can use a fraction there. Okay, you certainly can. So I'm going to use the 0.04. Now, the word of in math, it can often be substituted with the word with multiplication. So 4% of, or 1/2 of, or 2/5 of. You can use the word of to remind you to multiply. So this is going to be 0.004 times 2,000. And then probably you would need a calculator to do that. So 0.04 times 2,000, and that gives me 80. Now, $80 is the interest. Okay, so I would be earning $80 of interest. That might be one of the questions that you were asked. You might be asked, what is the interest? And you would bubble in 80. Okay, so you'd look for, I am earning $80 in interest. Now, the other question you might be asked is, what is your new balance? Well, that $80 interest, the bank is going to add that in to your $2,000. And so if you were asked the second question, you would need to do 2,000 plus 80, and you would get 2,080 as the new balance. But again, either question can be asked. You can be asked, how much money are you getting in interest and how much money do you have now? And you just have to read closely. It's just whether or not you need to do the addition at the end of the problem. All right, moving on. So as you add more money into the account, your principal increases. And the next time you earn interest, it will be even higher, even if the percent is the same. So if I go back to the previous problem and I earn 4%, now I'm earning 4% of 2,080, which means I'm going to earn a little bit more money. And every time your interest is calculated, even if the interest rate remains the same, you're going to be earning a little bit more money because that base number is going to continue to increase. So typically, interest is compounded at regular intervals or possibly continuously. Both formulas are exponential. And I believe these formulas are on your reference sheet, so you don't need to have them memorized. The formula on the right, which I notoriously forget because I never use it, is the total amount of money in your account is equal to the P, that's the principal, the amount that you put in. It says their initial principal balance. It's like the starting amount. And then you've got this lovely exponential there, 1 plus R over N And then all of that is raised to the nt. Now, it's the parentheses that are being raised, not the principal. So you do want to remember that. R is the interest rate as a decimal, and n is the number of times the interest is applied per time period, and t is the number of time periods that have elapsed. And so the nt is the total number of compounding periods that you have. The other one over here, I often will see this as A equals PE to the RT, and that would again be using the total amount. They have like P of T is the value at time T. It's like the final amount, or sometimes I'll call it the second amount. And then that P naught is just your original amount, or the amount of money at time 0. And then this is a natural exponential because the base is going to be that number E. Remember, I said that number just comes up. It's the base of the natural exponential. So we saw it come up this year in our little checkerboard activity, but it also comes up in science. It'll come up in math. Like, you're just going to see that number E. And then we have R times T is our exponent. Now, most problems of this type will involve knowing all but one of the numbers and needing to find the missing one. So pretty much if you see a problem like this, you need to read the problem, figure out which of those numbers you know, and then plug those numbers in, and you're going to have one thing left over that you don't know. That's the thing you need to find. You may or may not need your logarithms to be able to do it. It depends on what number you're being asked to find. So let's see if I can find my mouse. There it is. So here's a problem. You invest $2,000 at 4% interest compounded 4 times per year. How much money will you have after 5 years? So this, because you're told it is compounded 4 times per year, this is not compounded continuously, meaning that they're 4 times per year, your bank is going to add this number in. So that means you are using this formula here. Now, if you're going to use the other formula, it will say in the problem, compounded continuously. So now we need to figure out, okay, which of these numbers do we know? And then what are we looking for? So you invest $2,000. That means your principal is $2,000. So I am going to plug in 2,000 where I have the P. And then the 1 is going to be there at 4% interest. So the interest is 4%, but remember, we do need to change that to a decimal. So right here, I will have 0.04. It is compounded 4 times per year. So remember, the number n is how many compounding periods you have. So that would be 4. How much money will you have after 5 years? So n was 4 and t is 5. And so for our exponent, we'll have 4 times 5 because that's how many compounding periods we're going to have. We're going to have 20 total. 4 times per year for 5 years. So we're going to do 4 times 5 to get 20. What are we looking for? How much money will you have? So we are looking for that A value. So pretty much all we need to do here is dump those numbers in and use your calculator. If you are using Desmos, you should be able to dump this in as is. So you should be able to do the parentheses, the fraction, the exponent, all the things. Okay. I do not have Desmos where I can get it. Actually, I could use Desmos on my calculator here, or on my phone, to dump it in. So all I'm doing is, if you can see, I have Desmos pulled up, and I am just going to dump that in as best I can with the parentheses. 1 plus 0.04 divided by 4. Okay, that was right. Now I need to go outside and do the exponent. Now I'm going to do the 4 times 5 in my head. I'm just going to put the 20 in there. And my calculator tells me 2,440.38. Now you always want to round these to the nearest penny. Now it turns out the next number there is a 0. But if it were somebody calling me on my phone, I am recording a lesson, so I'm not going to pick it up. But so there we go. So that's that. So that's that formula. It is a bit of a beast. It is a little intimidating. So in your head, kind of think, okay, if you see something like that on your exam or on any exam, do you want to tackle it right away? Do you feel like, oh, that was just plugging stuff into a formula, I got this? Or do you feel more like, that formula is a little scary looking, I will star that one and I will come back to it and I'll go and see if maybe the next problem is a little bit better for me. All right. So the next one, I'm going to pause the recording for a second so that I can take care of some stuff. Hang on. Okay. I just realized this video is going to take a little bit longer than I have. I should be leaving my house in about like 15 minutes, and that's not going to happen with this video. So, all right. Problem number 2. How much money do you need to invest at 2.5% interest compounded continuously? So as soon as you see that, it means you're going to be using that other formula to have $10,000 by the end of 5 years. So as soon as you see compounded continuously, you're going to be looking at this formula, and I'm going to use the A equals P e to the RT. The version that I showed you earlier had like P of t equals P naught, okay, but it's all the same thing. So what do I know? I know that my interest rate here is 2.5%. Now keep in mind that we do have to change that to a decimal. So you can do 2.5 divided by 100, or you can move the decimal point over 2. And I wanted to make sure that I showed you something that had the interest rate as a decimal, the 2.5, just so you could see what that would look like. Okay, so your interest rate would go out 3 decimal places, so 0.025. Now it's compounded continuously. We want to have $10,000. So in this case, the amount that we want to have is $10,000, and the amount of time that we're investing it is going to be 5 years. So I was taught in school, like, make a list of all the numbers, like literally generate a list. So I have like the word rat written out there. And it helps you get your head around what are these numbers, and then where do I go to plug them in? So over here on the left, we're going to have the $10,000 over here equals the principal. That's what we're looking for. How much money do you need to invest? E to the 0.025 times 5. Now I can dump this into my calculator. Okay, and that's exactly what I'm going to do. Going to delete the last calculation I did, and I'm going to type in E and then hit my exponents. And I want 0.025 times, whoops, that kicked it out of the exponent. So I'm going to need parentheses. There we go. 0.025 times 5, close my parentheses. I've got way too much on the screen there. And it is giving me 10,000. Changed my green there. I didn't realize I changed my green. Equals P times 1.1331. Now we don't have any rules here for what, we want to, how many decimal places we carry it out. So that's multiplication. I'm looking for the p-value, so I will divide by whatever it is I am multiplying by. And so my next calculation is going to be 10,000 divided by 1.1331. And it is telling me $8,825. That 2 did not come out very clearly. And about 35 cents. Okay, so if I put into the bank today $8,825.35, it's actually 34.6 cents, but that's going to round up to 35. Then In 5 years, if that interest is compounded continuously at 2.5% interest, I will be at my $10,000. So that brings us to a problem for you to do. So you have $5,000 to invest and have chosen an option that has continuously compounded interest at a rate of 3%. How long do you need to invest the money in order for it to double? So go ahead, pause the video, identify which formula, see if you can identify where, like what numbers you have and what you're looking for, and then unpause it, and then we'll go over it together. Okay, I have a guy climbing a ladder like right outside my window. All right, so we have $5,000 to invest. So that's our principal. So we've got the $5,000. We know that the interest rate is going to be 3%. Don't forget to change that over to a decimal. And then it says how long. So we're looking for t in order for it to double. Now, there's a couple of ways that you can do this, but in this case, the final amount, if we want it to double, would be $10,000. Now, there are ways that somebody could give this to you and just say, how long would it take your money to double? And what happens is it actually doesn't matter how much money you invest. The amount of doubling would be the same no matter what. So this is continuously compounded interest. We want to have $10,000. We are starting with $5,000, and we know that interest rate is 0.03, and we're looking for t. This is going to need a logarithm. Before I can do the logarithm, I need to isolate the exponential, which means that we would start by dividing both sides by 5,000. And here's what I was talking about earlier, where it doesn't actually matter what number you start with. So if I had $3,000 and I wanted it to double to 6,000, or if I had 1,000 and I wanted to double it to 2,000, when you do this step right here and you divide, no matter what, you're going to end up with 2. So somebody could actually not give you that number and just say you want to double your money, and you just have a p, and the p's would cancel out and you'd be left with a 2. All right, so this is an exponential, so I'm going to try changing it to a log. So this would be log base e of 2 is equal to 0.03t. Remember that log base e is the natural log. And you will need a calculator to evaluate that. So I'm going to go and type into Desmos ln of 2, and I get, oh, I guess I'll move over here a little bit. I get 0.6931 is equal to 0.03t. And then I will divide by the 0.03 and find out how long do I need to keep my money in that bank account in order to double it. So 0.6931 divided by 0.03, and I'm getting about 23.1 years. Boom. So got to invest it for a while, but you can get it to double, just not anytime soon. And that gives you an idea of what, investments are. Low interest investments are usually pretty secure, but you do have to keep your money in them for a long time. You can make better interest, but it's higher risk, meaning that you could actually lose all your money. So, and that's where you might pay somebody to give you advice about what to do with your money, or maybe you would like to be the person giving the advice, in which case what you'd want to study in school is all these different options and what the risk values are. And there's a lot of probability and statistics involved in that as well. All right, so that's the new material. And now we're going to launch into the review. So hopefully this will go quicker. That actually took a lot longer than I thought it was going to be. So these are all from your study guide. So the first item on your study guide is know the shape of the different families of functions. To review, try sketching the shape of each of the following function types: absolute value, quadratic, linear, exponential, and square root. So you want to know, like, how do these different relationships look when they're graphed. So at any point in this, what you should be doing if you're doing this at home is you should be pausing the video to work the problems and then unpausing it to go over it. Okay, there's no replacement for you working the problems out, because on the test, I'm not going to be working them out for you. So you need to practice with it. But so go ahead, pause the video right now and sketch each of those functions. All right, so absolute value would look like a V shape, okay? And it could be either direction. Quadratic is the U shape, and again, it could be either direction. I didn't really make my absolute value pointy enough there. It should be pointy. A line, okay, looks like this, or like this, or like that, okay? Exponential is our new one. That can look like this. It can also look like that. So it's got that curve. That was that exploration activity. And then the square root looks like this. It's like the top half of a sideways parabola. And we had a bunch of different ways we could flip that around. Okay, so it's like a sideways parabola, but it's only one half of it. Those are your basic family types, if you see. Now, we've got polynomials as well, and we'll talk a little bit about rationals. Polynomials have a lot more variety, but they're essentially like lines and quadratics are polynomials. They're just really simple ones, and you can take it and like move it up and down and wiggle it all around. Okay. Number 2 is describe the transformations on an exponential function given the parent function. For example, if y equals 3 to the x is the parent function, what are the transformations on y equals negative 3 to the x minus 2 and y equals 3 to the negative x minus 4? So this was a part of that intro activity. Take a moment, pause the video, and you write what you think the transformations are, and then unpause it to review. Okay, so for this first one, the negative out in front flips it over the y-axis. Oh, no, that was over the x-axis. Ooh. So brain blip over the x. Oh, good grief, I can't even write it. That'll show me do this on long weekend. Flips over the x-axis, and then that minus 2 is going to make it go to the right 2. If you want to use Desmos to do this, then you can you look at the y-intercept is the best point to look at. This negative on this one is also going to be a flip, but this is a flip over the y-axis. And this, because it is not part of the exponent, means it will go down 4. So as I was walking around the room this past week, there were a lot of you that aren't paying attention to like whether something is a superscript or a subscript. So superscript would be like your exponent. Subscript could be like the base on a logarithm. And things are just starting to look like you're either not writing them at all or you're writing them incorrectly. So like your base should not have an exponent on it unless you're looking at photomath. Photomath does it, but I've never seen a human do it. And so you do want to be careful about that. You do need to notice it is important whether that like minus 2 is in the exponent, or the minus 4 is not in the exponent, because one of them is your left, right, and the other one is your up, down. All right, next one, be able to solve exponential equations by writing each side as a power of the same base. For example, solve 4 to the 2x equals 8 to the x minus 3. Note, if the directions say to solve the equation this way, other methods will not be accepted. So some equations can be solved by either this method or by using a logarithm. If you guys use a logarithm to solve this, I'm not giving you any kind of credit, because we haven't covered how to do that. It is solvable with a logarithm, but it's not the best way to solve it, and it's not the best way to solve it. So pause the video, see if you can solve this using the strategy provided, or by writing each side as a power of the same base, and then unpause it and we'll go over it. Okay, so for this one, remember the strategy here is to try to write the larger base as a power of the smaller base. And so you might start looking at, like, okay, 4 to the first power is 4, 4 squared is 16, and you realize, okay, I can't write 8 as a power of 4. Now 8 is a multiple of 4, but it's not a power of 4. So when that happens, you have to look for a smaller base. In this case, it would be 2. And so you start by, like, okay, 2 to the first power, 2 squared, there's our winner for the left. 2 to the third is 8, there's our winner for the right. So on the left, I replace the 4 with a 2 squared. And this is where the illustration of the super cool exponent club comes in. The super cool exponent club, which is the 2x, does not want the new member of the 2 to be able to get in there, and so it puts up its super cool exponent walls. On the right, we're going to replace the 8 with 2 to the third, and super cool exponent walls come into play. Once you have the same base on each side, then you can set the exponents equal. And so we would have 2 times 2x is equal to 3 times x minus 3. And you can have different kinds of equations here, but we typically keep them linear. So I'll go ahead and distribute. And so I have 4x equals 3x minus 9. We'll go ahead and subtract the 3x from both sides. And in this case, I get x is equal to negative 9. Yay. Next slide. Great. Be able to solve exponential equations using logs. Student laptops will be restricted to Desmos only, or you can use a handheld calculator. If you do not have your student laptop or cannot use it because it doesn't have a charge or there's something wrong with it, I will have a computer near my desk that you can access. So for example, solve 2 times 3 to the 2x minus 1 minus 4 equals 10, and e to the negative x plus 1 plus 3 equals 8. Pause the video, try to work these out on your own, and then unpause it, and we will go through them together. Okay, so remember that the first step when solving an exponential equation is to isolate the exponentials. So you do need to get these isolated. You cannot do multiplication before you do the exponent. So doing 2 times 3 is off the table. So if you caught yourself doing 2 times 3 is 6 because you thought, that'll be like way better. Nope, not way better. Can't do that. You're going to have to get rid of that 2 by doing division. And before we even do that, we are going to tackle this, because if you don't deal with that adding or subtracting first, you will probably not do the division correct either. So we're going to add 4 to both sides to get 14, and then divide by 2. And that'll give us 3 to the 2x minus 1 is equal to 7. And now that I'm looking at it, there's no way I have room to work both of these out in the same space. All right, now we're going to change that over to a log. So this would be log base 3 of 7 is equal to the exponent, 2x minus 1. And log base 3 of 7 needs to be dumped into a calculator. You can dump it in as is, or you can use the change of base. So you can do log of 7 divided by log of 3. There is no preference in this class for this test. I am going to, I don't know what I'm going to do. I think I'm going to do because I think it's easier because I'm doing this on my phone. I'm going to do log base 3 of 7, and it gives me 1.7712. And then I will add 1 to get 2.7712 equals 2x, and then divide by 2, and plus 1. And then I would like to divide this whole thing by 2 and get 1.3856 is equal to x. So pause the video here if you need to copy that down, okay? Because I am going to erase it imminently to work the next problem. All right, so the next problem is a natural exponential, which means we can use a natural log. And I actually worked one of these earlier in the financial part, so we're not going to belabor that. So same deal, we're going to get the exponential by itself, which in this case means we're going to start by subtracting the 3. So we have e to the negative x plus 1 is equal to 5. And then we'll change it over to a log. Now you can do log base e of 5 is equal to negative x plus 1. And if that step is kind of losing you, all right, then you know you need to go back and rewatch the video where we introduced it. And remember that log base e is just a natural log. So I am going to type in natural log of 5. And that is going to give me 1.6094 is equal to negative x plus 1. Go ahead and subtract the 1. And that's 0.6094 is equal to negative x. Now we had one of these come up in class, like we don't want negative x, we want positive x. So you can just move the negative, but the reason you can move the negative is because of this operational step. If you divide both sides by negative 1, of course they're going to stay equal. And then this would become negative over here. And a negative divided by a negative will give you a positive. All right. As always, pause the video there if you need to look at some of that work. And I'm going to move on to the next. Be able to expand and collapse logarithmic expressions using the properties. So for example, go ahead and expand this. So we have x squared over y to the third z, and collapse this one. All right, pause the video. Oh, that is missing something, isn't it? I don't know what I think there's supposed to be a z there. Ooh. 3 natural log z. And then I'll go over them. Okay, totally doable in one step. So what you should have gotten for this first one is, what should you have gotten? 2 log base 3 of x minus 3 log base 3 of y minus log base 3 of z. And I know that z is subtracted and not added because it is in the denominator. So it is entirely possible I will not take off points if you do not show work on these, because it's doable without doing any work. Now, if you do need to show the work though, please do. So in this case, we would do the log of the numerator minus the log of the denominator. But notice I did that it's subtracting like both the y and the z. So when you go to expand this, even though that's multiplication, both of them are being subtracted. So the multiplication, the subtraction actually gets distributed through the addition there, and then your coefficients would come down front. Okay. Easy little mistake to make. I honestly think the way I do it is I know if it's in the denominator, it means it's going to end up subtracted. Second one here, we're going to deal with those exponents. So we're going to have the natural log of x minus the natural log of y cubed plus the natural log of z cubed. And then the subtraction is going to collapse into division, and the addition is going to collapse into multiplication, which is going to land in the numerator. So it should be the natural log of xz to the third over y to the third. Anything subtracted going to land in your denominator. Anything added is going to land in your numerator. Almost done, which is good because I am actually going to be very late. That's where I'm supposed to go. All right, be able to solve logarithmic equations, including using the properties of logs. For example, solve this one. 4 log base 2 of x plus 3 is equal to 12, and log x plus log 5 equals log 20 minus log 4. So pause the video, work those out on your own, and then unpause it and we'll go over it. Okay, first one. Now you might be tempted on this first one to put the 4 in the exponent of the x plus 3, which you can do, but it's going to give you a quadratic polynomial, which you don't want to solve. Quadratic polynomial. So a better way to start off this first one is to recognize that you want to isolate your log. You have the 4 multiplying the log, and so it would be better to divide. 12 divided by 4 is 3, and now we'll change the log over to an exponential. That's one of our key strategies. So we'll have 4 to the third power is equal to x plus 3. 4 to the third power is 64, and then we can subtract the 3, and we will get x is equal to 61. And I'm kind of tempted to use my photomath to check it, but I won't. All right, so that one uses that first strategy of taking your log and changing it back over to an exponential, useful for when you have one logarithm on one side. You can isolate it. And if you did try to do like x plus 3 to the 4th, and then you'd end up with like 2 to the 12th power equals x plus 3 to the 4th, that should work. It should give you the 61, but I don't want to touch it. Like, don't do it that way. So if you need to pause the video and like just kind of revamp how you approach this one, please do. And nothing on your test is going to be that awful. So if you start doing the test and you start getting into something awful, like stop. There's an easier way to do it. You just have to go back and think, look, what did I miss? What's a different way to start the problem? On this one, on the left, we can combine the 2 logs that are added by multiplying the arguments. So that would be the log of 5x. And then over on the right, we can combine these by dividing the arguments. And 20 divided by 4 is 5. Once we have it written like that, we can set the arguments equal. So we'll get 5x is equal to 5. Divide both sides by 5, and x is 1. If you try to photomath that, I have this awful feeling that photomath is going to do something beyond hideous. Photomath is a great way to check your work, and it is sometimes a good way to, I'm looking at how they did it. um, Oh, I know what they did. Oh, okay. It's taking me a while to see what they did. All right. No, I still wouldn't do it that way. My way is still better. Um, yeah, so photomath, great way to check your work, but not a great way to do it out. If especially like it, I don't know, it's an algorithm, and computers and humans don't think the same way. So use it to check your work. If you've got questions about it, you know where to find me. All right. Last bullet point on your study guide is, given sample work, be able to identify and explain what the error is. So you're going to see something like, I don't know, like 4e to the x equals 8. I think this is like one that was on your homework, and it did this. And that was the only mistake in it. So, natural log base e of 4 is equal to x, like, and then whatever the decimal is. So there's only one mistake in it, so I will tell you that. And like, this would be the mistake, and basically you should divide. And so there'll be some work, you have to study the work, and then there's a little box, and it's going to say explain what the mistake is. Don't give more details than are needed. So some of you, and I appreciate wanting to answer our questions thoroughly, so I don't want to diss that, but some of you go into lots and lots of details, like they did this wrong, and here's all the things they should have done instead, and here's what the correct answer should be. If you were just asked to identify and explain an error, identify, explain the error, and stop. So in this case, you could say they subtracted 4 when they should have divided by 4. Leave it at that. So don't go and say, here's what the correct answer would be, because if you make a mistake, a different mistake in the rest of that, then you're forcing me to have to take off points, because now you're telling me stuff that's actually incorrect. So you do want to make sure you answer the question. And sometimes some of you will answer, the mistake is they did it wrong. I know. Why? So you want to give enough detail. Certainly a question I will answer during the test is, did I give enough detail here? Should I give more, or did I go too far? Should I like get, rid of this? And I'll give you some guidance on that during the test. All right, last little blurb, be prepared. If you are a senior in the 22-23 school year, this may be your only major test grade, because there's a good chance you're going to be done by the time we're ready to assess, or at least your grades will be done by the time we're ready to assess on rationals after your EOC, which means that this test has a huge impact on your fourth term grade, and you don't have another test to come in and cushion the blow should you mess it up really bad, okay? So take it seriously. Come prepared. Here's what you need to do to prepare. So we're not going to throw out like just study. Like, we want to make sure we know, what does it look like to study? First of all, watch the videos from all the lessons that you missed. If you slacked off when you missed class, you were testing during a class period, you got the plague, okay, and you were absent for a week, and you haven't watched those videos, you need to watch those videos. Algebra 2 is not just something you know. And this video is a review. So I did those problems pretty fast. You need to go back and watch those lessons, take those notes, make up the homework if you still have homework hanging out there, okay? Got to go back and plug that in. Now, for those of you that don't have, or you've already done that, right? Reread all the problems on this guide and rework them on your own. Not immediately. Take a day or two. Maybe do it the day before the test or 2 days before your test. Use your notes from this lesson to check and correct your work. So take every problem on this study guide, which you know was written from your test, and see if you can still work them out and plug in the gaps, okay? Check and correct your work. So if you're still making mistakes, go and get them fixed. Then develop a plan. Know which skills you're strong at and which are weaker. Start the test with your strong skills and work backwards. So no, I am good at this, this, and this, and I'm not as good at this, this, and this. And know when I hand you that test, which problems you're going to start with, because you want to start on the right foot. You want to calm your nerves down. You want to make sure that you're not getting so frustrated and anxious that you're leaving stuff blank. And last, work on the at-home test, as this will give you similar problems in a format where you can use your notes. The two tests cover the same material, but they cover it in different ways. So working on that at-home test before you do the in-class test is going to serve as a review as well. All right, so as always, you know where to find me. It's been a long video. Thank you for hanging with me to the end, and let me know if you have questions.